afternoon everyone. Today we are giving a presentation of threaded binaries with our group members Shreya, Seema and Varlakshmi, myself Purvi. Today we will learn what is binary tree. First we will learn what is binary tree. A binary tree is a structure made up of nodes. It is a tree which is made up of nodes. Each node is made up of two children, and it is a main group children, and these both are child nodes. It is the first one is left child node and it is a right child node. Means this is a root node. This are parent. This is parent. This is also called as parent node, and these both are child nodes, which we can go step by step. Here recursion is not allowed, and stack is also not allowed. Problem with the normal binary tree. In a normal binary tree, many child pointers are null. Means this both the child nodes are null. We cannot further use nodes representation is not allowed because that both are null, and during transversal we need a stack or recursion to visit all nodes. Here stack and recursion repetition is allowed while we are going to the node step by step. These stacks need extra memory and time. Because these both are null, that's why we need extra time and memory, because these both are null, and afterwards we can join by threads, and that will be used for further. Idea of threaded binary tree. Instead of keeping null pointers, we can use them for useful links. That both the child nodes are null, and if we use for them threads using the links, then we can use for further. We use these links to connect nodes directly in a specific order. Using threads, we will connect the nodes, and that will be used for further for specific order for stack and recursion. This helps to move easily from one node to another node without recursion. But step by step we are moving. Again we will go here. Again here one number and here one number. These both are child, and it is denoted as parent. And we can go with the step by step without recursion. And that too, the child pointers are used for further connecting the nodes easily by step without recursion. A threaded binary tree is a special type of binary tree. Here first we have learned what is binary tree. Now we will learn what is threaded binary tree. Difference between binary and threaded binary tree. Here null pointers are replaced with the threads pointing in order to proceed and succeed. In binary tree, both the child pointers are null, but here in threaded binary tree, why these two null pointers are used to link for another node, it makes transversal faster and uses memory efficiently. In binary tree, it will waste of time and memory will be wasted, but in threaded binary tree, memory and time will be not wasted, because this both the nodes will be connected by using recursion and stack, and further they will be used for linked list, and that threaded binary tree both will be used for link, and without pointers it is called as binary. The slides will be carried by Varlakshmi.
Varlakshmi, and we have to continue with why it is called threaded. Threads are like small rings or wires that connect nodes in order. They help to move from one node to the next without using a stack. Think of it like joining all the nodes together in a chain for easy movement. First of all, in a threaded binary tree, there will be present of many nodes. Each node has a stop on its own path. Each node will be having different paths. Basically, some of the paths will be missing. But in the computer, we need to call the stack for remembering for next which stop mile it is. But in threaded binary trees, we need not call the stack to find where we need to go next. Instead, here we join using the small connecting link, which is called as the thread. Small connecting link. This is small connecting link. The thread, it is used to connect the nodes. Like how we connect the necklace using the thread. In the same way, nodes are connected using the threads to move from one region to another region very easily. So here are types of threaded binary trees. The first one is the single threaded binary trees. The single threaded binary trees is usually one-sided. It has a thread. Usually it is of the right side. It is and here 10, 5. This is called as 5 is threaded to the 10. So here 5 is the in order. The single threaded is only considered of a right side, no left side. In right side it is of in order successor, not of predecessor. Successor means order when we are writing, it will be of next node, not of previous node. It is because it is only single threaded. Here we can write it as it is 5, 10. We can call it as 5 thread to 10. Not 10 is thread to 5. And by writing this in order, we can write it as. So this is the sequence. If this is the sequence, we consider here example of 5 and 10. It will be 5 here and 10 here. Because 5 is thread to 10, not 10 is thread to 5. So the next one is the double threaded binary keys. In double threaded binary keys, there will be two pointers, left pointer and right pointer. This both will be joined using the thread. Use first the left threader. It points to the predecessor. Left points to the predecessor and right points to the successor. Predecessor is the first one before node and successor is the next node. While this we can use this by taking three nodes which are 10, 5, 15. Here this is the right side and it is the successor one and it is the predecessor one. Here we can write this using fives right. Here we can call this as fives right thread to the 10 and 15's left thread to the 10. Here this is one single node which is joined using the two pointers. The pointers are 5 and 15 which are left and right. Next comes structure of the node. In simple C program, struct node int data, node pointer left, pointer right, bool left thread, right thread. So here why we use struct node only, because in nodes if we want to store any elements like data or values, it all is stored in the node itself only. So here we use as the structure node. Here int data. Data is used to store the values. If we want to put any values inside the node, we will use this int data. Here both left, right. These are the two pointers, left pointer and the right pointer. Usually the left pointer shows the left child and the right pointer usually shows the right child. The next one is the bool left thread, right thread. These are the threads. Here in the left thread, it shows the left pointer. If whether it shows about the left pointer, whether it is the normal thread or the child. And in right thread, it shows that about the right pointer, whether the right pointer is child or the thread. Then if suppose in the left thread, if left thread is true, then you can call that left pointer is a thread. If it is the left thread is false, then we can call that left pointer is a child. In the same way, right thread, we can call that if right thread is equals to true, then the right pointer is a thread. If right thread is false, then the right pointer is child. Thank you. The next one will be continued by Seema.
Seema. So here I am explaining how threading works. In a normal binary tree, there will be many left and right pointers which will be left out as null. Because if the null pointers are not used in the normal binary tree, and those null pointers will waste the memory, which is in order to change that which is going on into the waste, we are renewing it, and for that it is binary threading. So in binary threading, those null pointers will link to the next node. So here memory is not going into waste. So in binary thread, if node is not having left child, then it points to the predecessor in that successive way only, and if it is not having right child, it will link to the next node of the successor. And by using the binary threading, it will be saving the time and it will avoid recursion, which is causing the problems in the normal binary tree. So here in this example, 5 is not having right child, so we have to not waste that null pointer, so it is linking to the 10, and 15 is not having left child, so it is linking to the 10. So here it is the in order traversal. In simple way, we have to go to the left node which is present in the binary tree, and we have to copy down the node which is present in the left side, and then go to the successor one and then copy the data which is present in that node and repeat
repeat these steps until the binary trees each and every data is written on the given question. So here are the advantages of binary threading. In this, recursion will be not happening and we do not use a stack every time. In normal tree, recursion will be happening which will waste our time and the memory. So in order to reduce the wastage of time and memory, in binary threading we will reduce it. So we are not using recursion and it is faster traversal using threads. In normal trees, what will happen? If the null pointer is present, we have to go on checking whichever node we are searching in, we will have to go on check where is the node present. But in binary tree, as the null pointer is directly linked to the next node, so the time will be not wasted. Like very fast we will get the node which we are checking on. And it will save the memory by using null pointers. In normal binary trees, the memories will be going into the wastage, but in binary tree, memories will not be wasted. And it is simple access to the next and previous node in order. Because the null pointers or the normal null, these are directly linked to the left and right side. So here we will be accessing the nodes in a very simpler way. So here are the disadvantages. Insertion and deletion becomes more difficult. Every time when we go on inserting a node or deleting, the tree will be going on changing. So it will be difficult. Every time when we insert a new node or every time when we delete a new node, the structure of the tree will be changed. So that will be difficult for each and every step. And it takes extra space needed for thread flags. As we are inserting or deleting, it is becoming difficult, so space will be fluctuating as per the insertion and deletion. And it is not suitable for trees that change very often. As the binary trees, we are inserting and deleting, the structure of the tree is changing. So this is not very suitable to change, keep on changing. So the next one will be continued by Shreya.
Myself Shreya, and now I am going to explain the applications of the primary threaded trees. Application of the primary threaded trees are: it is used when transversal is needed many times, and expression trees are used in compilers and calculator, and then database indexing and searching, and it is useful for memory which is limited. An example for this is 10 threads, and these threads connect from 5 to 10 and 10 to 15 in order transversal, and no stack or recursion is needed in this binary tree. And lastly, we conclude that threaded binary trees makes transversal faster and save memory, and it saves the memory. They reuse null pointers to form useful links, and that are called as threads. And it is in a simple and smart way to improve binary tree performance. We use in a simple and smart way to improve the binary trees. And by this we conclude our seminar.